In this video, we're going to look at naming a class of compounds called hydrates, which you're pretty likely to encounter when you're taking chemicals off the shelf in a stockroom. And you also encounter them if you're studying geology, because most of the time minerals are hydrate compounds. They're the type of compounds that we're going to talk about here. Now, let's give you an example. There's a mineral called blue vitriol. It has big blue crystals. They're beautiful. They look like sapphires. And they're based around a copper-2 ion. Each copper-2 ion has parked around it, 4 water molecules. Why? Well, it's positively charged. And remember, water molecules are polar in the sense that the oxygen is negatively charged. It's the more electronegative element between hydrogen and oxygen. So this part of the molecule has a negative charge. And a negative charge is attracted to a positive charge. So there's just enough room for 4 of these to park themselves around the copper. Now, another water can sit out here, and it is kind of attracted to those hydrogens because it's got a negative charge on its oxygen. And these hydrogens are stuck to a sulfate. Now, we're going to draw the structure of a sulfate very shortly. We're going to start to do this kind of thing in the next worksheet, actually. But think of this whole thing as having a -2 charge, and I won't write all the details of the structure in here. Let's keep it simple. But that's a sulfate ion, and this positively charged hydrogen can stick to the negatively charged oxygens on the sulfate. This big thing here is the unit that repeats over and over again in a crystal of blue vitriol. Now, this is too much detail for us here in Chem 201. You'll study this kind of thing in more detail if you take inorganic chemistry. And if you take geology, you're looking at crystal structures there. But we're going to write this in a simplified way. There's copper-2 sulfate in there. And there are 1, 2, 3, 4, 5 waters holding this structure together. These waters are called waters of crystallization. And they lock in there in a definite ratio. There are 5 waters for every copper-2 sulfate unit that are in there. So how would I name this? The common name is blue vitriol, but what would be the chemical name? We're going to name it like we're going to name the ionic compound part just the way we always have. And this part here we're going to call the hydrate part because it's got water in it. And for this number, we are going to use those prefixes that we used for covalent compounds. For 5, it's penta, so we'll call this a pentahydrate. Now, before we go on, notice that there are 2 things that are different about this formula than any formula that we have done up until this point. One thing that's different is that we've got this dot here. This dot means that these are held together in the crystal, but they're not strongly bound to the ionic compound. They can be driven off. In fact, if you heat blue vitriol, if you bake it, you'll drive all the water off. This water will go away, and you'll just have copper-2 sulfate, and the crystal structure will be destroyed. It no longer has the water molecules to glue it together like this, and you'll get this crumbly white powder instead of this bright blue crystal. So that dot is showing you that the waters are loosely bound there. And the other thing is how many waters we've got. It says there's 5 waters here. So this 5 multiplies everything, and it's not a subscript. This is the first time we've written a number in a chemical formula that isn't a subscript or a superscript for a charge. This means that there are 5 waters, so there are 10 hydrogen atoms here and 5 oxygen atoms. Okay, let's name this thing. Now, let's write the name again down here so that we can keep things from being cluttered. I'm going to name the ionic part the way I usually do. I've got to figure out what the charges on these things are. Now, I would not know the charge on the copper, but I would know the charge on the sulfate. SO4 is in my list of common polyatomic ions, and I would know that it is a -2 charge. The only way I'm going to know that is if I memorize that list that we talked about in the last worksheet. Now, if this has a -2, that has to have a +2. So this part is a copper 2 ion, and now I have to use the Roman numeral because it's a transition metal. And then sulfate. Now, when you're typing this as an answer into a problem, there is no space here, remember, and there is a space right there. And keep it all lowercase. This is not a proper noun. So type all these things in the lowercase. Of course, the Roman numeral has 2 uppercase I's in there. Okay, 5H2O. We're going to use the prefix from the covalent compounds for the number there. So that's penta for 5. And hydrate is what I say for the water. So the penta stands for the 5, and the hydrate stands for the water. So if I give you a formula, I want you to be able to write the name out this way. And I want you to be able to go the other way, too. Here is washing soda. This is what you buy when you've got very hard water and you want to soften it. It's a water softener. It's this compound, sodium carbonate decahydrate. Let's write the formula from this. Okay, the sodium ion is Na+. I know that from the periodic table. The carbonate ion I know from my polyatomic ion list. Do you know what it is? You should. Carbonate. Now, you need to memorize these. Now, let me tell you why. Because we're going to use this a lot more, not just for naming compounds, but we're going to use it in a future chapter where we write out chemical equations for reactions. And if you don't know your polyatomic ions by then, you're going to be lost. So buckle down and memorize that polyatomic ion list now so that it doesn't keep on causing problems for you in future chapters. Deca means 10, and hydrate means water. So here's all the little pieces. Let's put the pieces together. Okay, if carbonate has got a -2 charge, I'm going to need 2 sodiums with that. So when I push these things together, I get sodium carbonate. It looks like that. And now I'm going to hook on the waters. Dot 10 H2O. That would be the formula for washing soda. Let's do another one. Here's the formula for Epsom salt. Epsom salt is something you buy in a drugstore. People use it as a bath salt. It is this formula. Let's name it. All right, I'm going to look at the ions that I have in here. From the periodic table, that's an Mg+2 ion. I know this is a sulfate ion. So all I have to do is name them. Magnesium. I don't have to say magnesium Roman numeral 2 here because this is not a transition metal. It is not in that area where you have variable charges. Magnesium ion always has a +2 charge. And this is a sulfate ion. I know that from my polyatomic ion list. And 7, what's the prefix for that? If you said hepta, you're right. And then for water, this will be heptahydrate. I make this last part all one word. So that's how you name these. There are several in the worksheet, and you'll see several more in the homework, and a few on the next test. So practice this.